Bolaji YouTube channel is presenting a biostatistics lecture on the freedom, degree of freedom, and that is a very special concept in the biostatistics and how it evolved and what is its importance and what are its practical applications are the main objective of this lecture. So let us start, and if you are new on the Dr. Hussain Bolaji YouTube channel, please subscribe it, like it, and in the comments below you should have any comments, query, or any addition you want, or any topic you want to be covered. This lecture is meant basically for the FCPS, MCPS, MPH, MSPH, and even MPhil and PhD degree, but particularly I am just supervising the MCPS students, so I am preparing this topic for their curriculum as well as for the information of undergraduate, whether they are from the nursing side, PSC nursing, MBBS, or dental side, or even now MSPH or BSPH, Bachelor in Public Health Sciences. So let us start. The topic is, my camera will show you the degree of freedom in biostatistics and MCPS community medicine, and you can see this very embarrassing picture where you can see that the degree of freedom is unlimited, but in biostatistics this is not the case. The degree of freedom concept is number of observation in the data that are free to vary, and ultimately you can have a limitation or restrictions in the data we will discuss and the estimate in the parameters. So it refers to maximum number of logically independent values that have the freedom to vary logically or practically. The number of independent values in the sample and number of independent way in which dynamic system can move without violating any constant imposed on or constraint imposed on that. We will see. So this was the Carl Friedrich Gauss as early in 1821, and you can see its birth and other data which I can show you that this was the John Carl Friedrich Gauss, 30 April 1777 was born and died on 23 February 1850. So you can see that the concept of the freedom of degree is not new one, and this was the originator, and we will discuss also. And here you can see the standard deviation is the formula under root x minus x bar square n. So this is the area where degree of freedom plays its role, and here is the sample. Suppose this is a sample, the total sum is 69, but there are certain parameters, but in the 10th value you can see that you have to 1 degree, or you will not have any freedom. You have to put to complete the 69. So that is degree of freedom. You can have this data, whatever, you can have 4, 8 or 8, 4, 6, 3 and so on and so forth. But at the end it is only 1 degree freedom, so it is n minus 1 in the standard deviation. We call it degree of freedom. You can see the different pictures, and you can see that they are not equal, so there is deviation. And here also, if you count the days worked and some kind of other things, then you can have something at your freedom, but at the least you can have 7 days in the week. So if you will count it 4, 5, then the 7 will be the last freedom or degree of freedom. And then you can see this n minus 1. This is basically a degree of freedom, and which I have shown in the sample earlier, which you can see again in the this. So you can have 9 at your disposal, but the 10th is only a fixed one, or degree of freedom of 1 degree freedom. You can see this kind of estimates here. You can use it, and standard deviation, skewness, kurtosis, these are the words used in the biostatistics. And then coming to the basically you can see that the degree of freedom in regression, how does water temperature affects the number of spikes found on the sea of urchins. So if the temperature rises and then the spikes, they are rising, and you can count it and you can have a degree of freedom in the sample. This was William Stanley Grosset in 1980, the founder or the father of the biostatistics. So the survey for collection of data of human community first time used a statistical tool to study difference among human population. He created the statistical concept of correlation also. Then coming to the other side, degree of freedom is denoted as DF, and here I bring the concept to life in an intuitive manner. However, quickly move to the practical example, and degree of freedom definition is clearly what are the degree of freedom in statistics. Degrees of freedom are the number of independent values that a statistical analysis can estimate. So number of values which you can freely, and you can also think it as the number of values that are free to vary as you estimate the parameter. Degree of freedom encompasses the notion that the amount of independent information you have limit the number of parameters that you can estimate. Then coming to the this again same picture, and I am just showing you the T distribution. Then you can see the degree of freedom. The maximum number of logically independent values, which are values that have the freedom to vary in the data sample. So you can have 4 here, 2 here, 4, 3, 5, 1, but ultimately the sample size will have a degree of freedom. At the end it can be n minus 1. And this is another picture showing the degree of freedom, but here the calculation of degree of freedom, it is used in the degree of freedom are calculated by subtracting the number of restrictions placed on a set of data from the total number of data points. So if the total is 20, then you can vary, but one figure you have played at the end. Second degree of freedom are important because they are different. They affect the precision of the statistical estimate. And last, the degree of freedom can also be used to calculate the critical value of the statistical test, chi-square test, t-test, z-test, and even other tests you can have. So coming to the degree of freedom, its uses, this chart shows it. And once again, the degree of freedom is the data in the sample where you can have at least many things here are values, but at least if the total values are fixed, are restricted, then degree of freedom will be n minus 1, or it will be 1 degree of freedom. And degree of freedom tables are there from which you can calculate the critical value. So I think with this I am ending this lecture, and the question asked from students in MCPS, FCPS is what is degree of freedom, how it is calculated, and what is n minus 1. So n is the sample and minus 1 is the degree. This is used in the standard deviation as well as in the calculating the test of significance or p-values, so on and so forth. And once again I am just showing that this is not a degree of freedom just like a bullet or anything, but it is a statistical concept. And here you can see that you can vary in the sample all these values, but the last value will be fixed, that is n minus 1. So this value is called degree of freedom, so that the value must sum to the 69 based on the equation for the mean. So if this is 69 and there are 10 values, you can vary values up to the 9, but the 10th value will be fixed, so that is called degree of freedom. You have 1 degree of freedom. So if you have liked this video and this concept, please subscribe, like, share, and have a comments box. Leave some comments, and I hope this lecture will give you a concept of the degree of freedom. And once again I am repeating the maximum number of logically independent values that have a freedom to vary in the data sample. And once again, this is a value, 10 values, 9 you can select at your own, but 10 will be the fixed value, so we call it 1 degree of freedom in a statistical concept. Thank you very much.